In this video, we're going to discuss the solutions to the review for Quiz 4. It covers vector-valued functions and planar curves. So, in the review, we are given the vector-valued function r of t equals t squared minus 3, comma, 2 minus t. T ranges between negative 3 and positive 3 inclusive. So the first thing I'm going to do is calculate r of negative 1, since all that involves is a simple substitution. So if we substitute in 1 for negative 1 for t, we're going to get 1 minus 3, that's negative 2, and then 2 minus a negative 1 would be 3. Before we can find r prime of 1, we need to find r prime of t. And that's going to be 2t, comma, negative 1. When we substitute in negative 1 for t in r prime, we're going to get negative 2, comma, negative 1. Alright, so we've got this vector and that vector. Now we need to plot some points so that we can sketch the graph of the vector-valued function. I'm going to make a table of values, and I think we can get away with looking at just the integer values of t. So I believe we're going to get the numbers 6, 1, negative 2, negative 3, negative 2, 1, 6 for x, and then for y we should get 5, 4, 3, 2, 1, 0, negative 1. So now we're going to graph the plane curve. So my first point is where x equals 6 and y equals 5. That'll be right there. Here's the x-axis. Here's the y-axis. Then we have x equals 1, y equals negative 4, 1, x equals 1, y equals 4, then x equals negative 2, y equals 3, x equals negative 3, y equals 2, x equals negative 2, y equals 1, x equals 1, y equals 0, x equals 6, y equals negative 1. Alright, and so there is our graph. I shouldn't have gone past that point. I should have stopped right there. I'll just enlarge the point and cover up my mistake. Now this is where t equals negative 1, this is, negative 3, t equals negative 2, and so on. So the orientation is going to be in this direction. Remember, the orientation comes from the fact that the values of t are increasing as we go in this direction. So we are asked to graph r of negative 1. That's the position vector at negative 1. Well, when we did this table, I've been talking about these points like they are components of a vector, and they are, but we also want to think of them as coordinates of a point. We also want to think of this as the point negative 2, 3. And so what we would like is we're going to draw a vector, but we want it to end here. We want the end point to be negative 2, comma 3. So that means we need to make the initial point the origin. So we construct the vector negative 2, comma 3. And it looks kind of like that. R prime of negative 1. Right? That is the point where t equals negative 1. the point has coordinates negative 2 and 3. Now, we also need to sketch in the velocity vector r prime of negative 1. We probably do not want to sketch this with the initial point at the origin. With the position vector, we always start with the initial point at the origin. We usually do not do that with the velocity vector. Remember that this is also a tangent vector. Where is it tangent to the curve? It's tangent to the curve at the point where t equals negative 1. It's tangent to the curve at this point, not at the origin. The curve doesn't even go through the origin. So remember, this is not only a velocity vector, it's also a tangent vector. So if you draw it with its initial point here, you're completely missing the point of it being a tangent vector. And actually, you're actually missing most of the point of it being a velocity vector. So let's go back up here and sketch in the vector. I believe it was negative 2, negative 1. And if we go negative 2, negative 1, we'll end up right there. I need to turn this around briefly. There we go. There is r prime of negative 1, or v of negative 1 if you want to call it that.